Hello everyone and welcome. I'm excited to have you here today. We're about to dive into an introduction to Python. On this first slide, you'll see the title, Introduction to Python, and there's a subtitle if you'd like to note it down. Over the course of this presentation, we'll explore what Python is, why it's so popular, and how you can start using it yourself. We'll cover the basics, some key features, and practical examples. But for now, let's get started and enjoy this learning journey together. Let's take a quick look at what we'll cover in this presentation. Starting with the overview, we'll explore what Python is and why it's so popular. We'll also look into the different features that make Python a great choice for developers. Moving on, we'll see who uses Python and examine the history of its releases. As we progress, we'll delve into core concepts like syntax, indentation, and data types, which are fundamental to writing Python code effectively. We'll also cover important topics like lists, dictionaries, and string manipulation, showing how Python makes data management straightforward. Control flow structures, such as if statements and loops, will be discussed, along with functions and how to use them to organize your code. We'll explore object-oriented programming with classes, inheritance, and class attributes, giving you a solid grasp of Python's approach to designing programs. Additionally, we'll look at best practices like comments, documentation, and error handling to write clean, maintainable code. We'll also touch on Python's ecosystem, including tools, IDEs, package management, and popular web frameworks. Finally, we'll see some advanced topics like generators, list comprehensions, and resource links for further learning. All of these points come together to give you a comprehensive understanding of Python, preparing you to start coding confidently. Let's take a quick overview of what we'll cover in this section. First, we'll look at the background to understand the context and foundation of what we're discussing. Then, we'll delve into syntax, which is essentially the rules and structure of the programming language. Moving on, we'll explore the different types, operators, and control flow mechanisms that allow us to manipulate data and control how our programs run. We'll also examine functions, which are the building blocks of reusable code, followed by classes, which introduce object-oriented programming concepts. Lastly, we'll touch on some useful tools that can help streamline our development process. This overview sets the stage for a comprehensive understanding of the core elements that make up this programming approach, tying everything back to the overall theme of mastering the language efficiently and effectively. Let's talk about what makes Python really special. First, it's a multi-purpose language, meaning you can use it for web development, creating graphical user interfaces, scripting tasks, and much more. This versatility is a big part of its appeal. Next, Python is both strongly typed and dynamically typed. That might sound a bit technical, but essentially it means that Python is strict about data types when needed, but it also figures things out on the fly, making coding faster and more flexible. It's also an object-oriented language, which means it organizes code into objects. Think of these as real-world entities with properties and behaviors. This approach helps keep your code clean and manageable, especially as projects grow larger. A core focus of Python is readability and productivity. The language is designed so that code is easy to understand, not just for you, but for anyone else reading it, which speeds up development and collaboration. Finally, Python is an interpreted language. Instead of compiling your code beforehand, Python reads and executes it line by line, which makes testing and debugging much more straightforward. All these features together make Python a powerful, flexible, and user-friendly language, perfect for a wide range of programming tasks. Let's take a closer look at some of Python's key features that make it so powerful and versatile. First up, batteries included. This means that Python comes with a rich standard library out of the box, so you don't need to rely on external modules for many common tasks. It really speeds up development. Next, the interactive shell is a huge advantage. It allows you to write and test code snippets on the fly, making experimentation and debugging much easier. It's perfect for learning and quick prototyping. Moving on, cross-platform is another major feature. Python code runs seamlessly across different operating systems like Windows, Mac, and Linux, giving you the flexibility to develop and deploy applications broadly. The point that everything is an object is fundamental. In Python, even functions and classes are objects, which means you can treat them like data, pass them around, modify them, and use them dynamically. This makes the language very flexible and expressive. Strong introspection refers to Python's ability to examine objects and their properties at runtime. This feature empowers developers to write more dynamic and adaptable code, and it's especially useful in debugging and development tools. Finally, Python has multiple implementations like CPython, Jython, IronPython, and PyPy. Each serves different needs, whether integrating with Java, Net, or optimizing performance, showing how adaptable Python is across various environments. All these features together reinforce Python's reputation as a user-friendly, powerful, and flexible programming language, aligning perfectly with our overall theme of accessible and efficient coding. Now, let's take a look at some of the key players who are actually using Python in their day-to-day operations. When we think about big names like Google, Python plays a crucial role in powering services like YouTube, which is one of the most visited websites in the world. Then we have IBM, a giant in the tech industry, utilizing Python for various data analysis and AI projects. NASA also relies on Python for scientific computations and data processing in their space missions. Instagram uses Python extensively to manage their backend services, ensuring smooth user experiences. Dropbox, a popular file hosting service, built much of their infrastructure with Python, enabling scalable and reliable storage solutions. And Mozilla, the organization behind Firefox, leverages Python for developing and maintaining their web browsers and other tools. What's really compelling here is how these diverse organizations, from tech giants to space agencies, all rely on Python. It underscores Python's versatility and its integral role across different industries and applications, which ties directly into our broader theme of understanding why Python is such a powerful and popular programming language today. So, when we look at the growing popularity of Python, we see that it's widely adopted across various major companies. For instance, Yahoo is a notable user, leveraging Python for their data processing and web development needs. Red Hat also uses Python extensively, especially in their open-source solutions and automation tools. And this list doesn't stop there. Many other organizations rely on Python for different applications. For example, Quora employs Python to build scalable and efficient question and answer platforms. GitHub, the hub for open-source projects, also utilizes Python, especially for automation and backend services. Reddit, one of the largest social platforms, depends heavily on Python for its backend development. Cisco, a global leader in networking hardware, uses Python for scripting and network automation tasks. What this really highlights is that Python's versatility and ease of use make it a favorite among industry giants. It's not just a language for beginners, but a powerful tool that supports complex, large-scale operations. This widespread adoption reinforces the theme of the presentation, Python's growing influence and its role as a key technology in innovation and enterprise solutions. Let's take a quick look at the releases in Python's history. Python was created back in 1989 by Guido van Rossum, which marks the beginning of its journey. Then, in 2000, Python 2 was released, bringing in many new features and improvements. Among the Python 2 versions, 2.7 is considered the most stable and recommended for use today. Going further back, Python 1 was introduced in 1994, laying the foundation for what was to come. The major milestone came with Python 3, released in 2008, which introduced significant changes to improve the language, but also meant some backward compatibility issues. Currently, the latest version available is Python 3.6, which includes many modern features and enhancements that support current development needs. These release milestones highlight how Python has evolved over the years, continually improving and adapting to the demands of programmers worldwide. This history of releases connects directly to the overall theme of Python's growth and maturity, as a powerful, flexible programming language. Let's take a closer look at the Hello World example with the Hello World Py file. This is often the first step when learning a new programming language, and it serves as a simple way to verify that everything is set up correctly. In this case, the file name clearly indicates its purpose: to output Hello World to the screen. The key point here is understanding how a basic script like this demonstrates the fundamental syntax of the language. It shows how to write a simple command that the computer can execute to produce an output. This example is especially important because it builds confidence. You see immediate results after running the code. Connecting this to our overall theme, Hello World is not just about the greeting itself. It's about the first successful interaction with the programming environment. It marks the beginning of your journey into coding, where you'll learn to craft more complex programs. So, keep in mind that mastering this simple script lays the foundation for everything that follows. Let's talk about indentation. Many programming languages don't actually care about indentation at all. They focus on the code's logic and syntax rather than how it's spaced out. But as humans, we tend to group similar things together to make sense of complex information. Most of us naturally do this. It's a way our brains organize data. Now, this is where indentation really shines. It allows us to write code that isn't just functional but also beautiful and easy to read. Proper indentation helps us see the structure at a glance, making maintenance and debugging much simpler. So, even if the language doesn't require it, using indentation thoughtfully aligns with our goal of writing clear, elegant code. It's a powerful tool that bridges the gap between machine and human understanding, reinforcing the overall theme of writing code that's both effective and approachable. So, in this slide, we're diving into indentation and how it affects our code structure. Now, the key point here is that the else statement actually belongs to the second if statement. This might seem a bit tricky at first, but it's all about understanding how indentation defines the scope of each control structure. When you see the else aligned with the second if, it clearly indicates that it's paired with that specific if. This is important because proper indentation ensures our code runs as intended and makes it much easier to read and maintain. Remember, in Python, indentation isn't just about style. It actually determines how the code executes. So, paying close attention to how you indent your code helps avoid bugs and confusion later on. This concept ties into the overall theme of writing clear, understandable code that behaves predictably. Now, let's talk about the importance of indentation in Python. Python actually embraces indentation as a core part of its syntax. Unlike many other programming languages that use curly braces or keywords to define blocks of code, Python relies on indentation to structure the code visually and logically. This means that the way you indent your code isn't just for readability, it's mandatory for the code to run correctly. Proper indentation helps clarify the flow and hierarchy of your program, making it easier to understand and maintain. So, when you're writing Python code, always pay close attention to indentation, because it plays a crucial role in ensuring your program works as intended and remains clean and readable. Let's take a moment to discuss some comments on the previous slides. First, I want to emphasize that feedback is essential for continuous improvement. It helps us identify what's working well and where we can make adjustments. When sharing comments, it's important to be specific and constructive, focusing on actionable insights. This way, we can foster a positive environment where everyone feels encouraged to contribute. Remember, the goal of sharing comments is to support growth and innovation, aligning with our overall theme of collaboration and progress. So, I encourage you to keep the feedback coming, always aiming to build on our strengths and address challenges effectively. Today, I want to talk about strings. Strings are fundamental in programming because they allow us to work with text. They can contain anything from words and sentences to characters and symbols. When we think about strings, it's important to understand that they are sequences of characters, stored in a specific order. This means we can manipulate and analyze text data effectively. Strings are used everywhere, in user input, displaying messages, or handling data like names and addresses. They're versatile and essential for creating interactive and user-friendly applications. One key concept to remember is that strings are immutable in many programming languages, meaning once created, they cannot be changed. Instead, any modification results in a new string. This influences how we work with and optimize our code. Overall, understanding strings is crucial because they form the backbone of data handling in most software development tasks. They connect to the broader theme of programming by illustrating how we manage and manipulate textual information efficiently. Let's take a closer look at some of the key numbers that really highlight the importance of this topic. Numbers can often seem dry, but they tell a powerful story. For example, when we talk about growth or impact, the figures help us understand the scale. It's essential to focus on the most relevant data points that support our overall message. Sometimes, a single statistic can be more persuasive than a lengthy explanation. These numbers also help us track progress over time and set measurable goals moving forward. Remember, behind every number is a story, whether it's success, challenge, or opportunity. Connecting these figures to real-world implications makes the data more meaningful and inspires us to act. So, as we move through this, keep in mind how these numbers fit into the bigger picture of what we're trying to achieve together. Let's talk about lists. Lists are a fundamental tool in organizing information clearly and efficiently. They help break down complex ideas into manageable parts, making it easier for your audience to follow along. When used effectively, lists highlight key points and ensure important details aren't overlooked. There are different types of lists, like bullet points or numbered lists, each serving a slightly different purpose. Bullet points are great for unordered items or ideas, while numbered lists work well when the sequence matters, like steps in a process. Using lists also creates visual breaks in your content, which keeps your presentation engaging and easy to scan. This ties back to our overall theme of clear communication, making sure your message is accessible and compelling. Remember, the goal with lists is to organize your content in a way that enhances understanding and retention. When used thoughtfully, they can make your presentation much more effective. Let's take a closer look at dictionaries. Dictionaries are a fundamental part of programming because they allow us to store data in key-value pairs. Think of them as a real-world dictionary where you look up a word and get its definition. In programming, the key is like the word, and the value is the definition or the information linked to that word. What makes dictionaries so powerful is their ability to retrieve data quickly, which is especially useful when working with large datasets. They're flexible because the keys can be of various data types, like strings or numbers, and the values can be anything from numbers to lists or even other dictionaries. Dictionaries also make our code more readable and organized. Instead of managing multiple variables, we can group related data together in a single dictionary. This aligns with the overall theme of efficient data management and how we can structure our code for clarity and performance. So, understanding how to create and manipulate dictionaries is a crucial skill that enhances both the efficiency and readability of our programs. Now, let's move on to slide 19, which is all about dictionary methods. In Python, dictionaries are incredibly versatile, and understanding their built-in methods is key to leveraging their full power. These methods allow us to access, modify, and manage data efficiently. For example, methods like get help us retrieve values safely without risking errors if a key doesn't exist. The pop method enables us to remove items and keys, values, and items, help us explore the contents of a dictionary. Recognizing these methods and knowing when to use them is essential because they make our code cleaner and more effective. Connecting this to our overall theme, mastering dictionary methods empowers us to handle data structures more confidently, which is fundamental in programming. Now, let's move on to slide 20, which is all about Booleans. Booleans are a fundamental concept in programming and logic because they represent one of two states, true or false. These values are essential for making decisions in our code, such as checking whether a condition is met or not. For example, if a user is logged in, a Boolean might be true. If not, it would be false. We often use Booleans in conditional statements like if-else blocks to control the flow of our programs. Understanding how to work with Booleans is key to creating dynamic and responsive applications. So, in essence, they serve as the binary switch that guides decision-making processes in programming. Let's take a closer look at arithmetic. This section is fundamental because it forms the basis for many of the calculations we'll encounter. Arithmetic involves basic operations like addition, subtraction, multiplication, and division. These are the building blocks for more complex mathematical concepts. Understanding how these operations work and how to apply them accurately is crucial, especially when dealing with real-world data and problem-solving. Throughout this presentation, you'll see that mastering arithmetic helps us interpret information correctly and make informed decisions. So, as we move forward, keep in mind that a strong grasp of arithmetic is essential for everything else we'll explore. Now, let's move on to slide 23, which focuses on string manipulation. This is a crucial area because working with text data is incredibly common in programming. When we talk about string manipulation, we're referring to various techniques that allow us to modify, analyze, or extract information from text. For example, you might want to change all the characters in a string to uppercase or lowercase, or perhaps you need to find a specific word within a larger piece of text. These are everyday tasks when handling data input or preparing output for users. One important concept here is the use of built-in string functions, which make these tasks much easier and more efficient. Functions like slicing, concatenation, or searching help us manipulate strings seamlessly. Understanding string manipulation is essential because it ties directly into the overall theme of programming, making our code more flexible, dynamic, and user-friendly. It enables us to handle text in ways that make our applications smarter and more responsive. Let's talk about logical comparison. When we're comparing things logically, we're really focusing on the relationships between different data points or statements. The key here is to understand the different types of comparison operators, like equal to, greater than, less than, and so on. These operators help us make decisions in programming or analysis by evaluating whether one thing is related to another in a specific way. It's important to note that logical comparison isn't just about checking if two values are the same. It's about understanding the nuances, like whether one value exceeds another or if two values are not equal. This forms the foundation for decision-making processes, whether in algorithms, business logic, or everyday reasoning. Connecting this to our overall theme, logical comparison is what allows us to create conditions and rules that guide behavior or outcomes. Without it, we'd be unable to automate decisions or draw meaningful conclusions from data. So, mastering these comparison concepts is essential for building effective, logical systems. Let's take a closer look at identity comparison. This is a crucial concept because it helps us understand how different entities or data points are evaluated for similarity or equality. When we compare identities, we're essentially asking whether two things are the same or belong to the same category. This is fundamental in many systems, whether it's verifying user identities, matching data records, or ensuring consistency across datasets. The key point here is that the way we perform these comparisons can significantly impact the accuracy and reliability of our overall system. For example, strict comparisons might be too rigid and miss genuine matches, while more lenient comparisons could lead to false positives. Connecting this back to our overall theme, effective identity comparison ensures integrity and trustworthiness in our processes, which is essential for dependable data management and decision-making. Let's take a closer look at arithmetic comparison. This is a fundamental concept that helps us evaluate and compare different quantities or values. When we perform arithmetic comparisons, we're essentially asking questions like, is this number greater than, less than, or equal to that number? These comparisons are crucial because they form the basis for decision-making, sorting, and many other processes in data analysis and programming. The key points to remember are the comparison operators, such as greater than, less than, equal to, not equal to, greater than or equal to, and less than or equal to. These operators enable us to establish relationships between numbers and make logical decisions based on those relationships. Understanding arithmetic comparison is important because it connects directly to the overall theme of data evaluation. Whether we're filtering data, validating inputs, or controlling the flow of a program, these comparison techniques are foundational. They help us interpret data accurately and make meaningful choices based on that data. Let's take a closer look at conditionals. Conditionals are a fundamental concept in programming because they allow us to make decisions within our code. Essentially, they let us specify certain conditions that, when true, trigger specific actions. For example, if a variable meets a particular criterion, then a block of code runs. If not, it might skip that part or execute something else. This is what makes our programs dynamic and responsive to different situations. Most programming languages have simple structures for this, like if statements, which check a condition and then execute code if that condition is true. You can also have else and else if parts to handle other cases, making your code more flexible. Understanding conditionals is crucial because they connect to the overall theme of creating intelligent, adaptable systems. They allow us to implement logic that mimics decision-making, which is at the heart of programming. So, mastering conditionals is key to developing more complex and useful programs. Let's talk about the for loop, an essential tool in programming that helps us automate repetitive tasks. The key idea here is that a for loop allows us to execute a block of code multiple times, which is incredibly useful when working with collections of data or performing repetitive operations. What makes for loops powerful is their ability to iterate over a sequence, like a list or a range of numbers, with minimal effort. Instead of writing the same code over and over, we set up a loop that automatically runs through each item, saving us time and reducing errors. In the context of our overall programming theme, for loops are fundamental because they enable us to write more efficient and cleaner code. They help us process data systematically and can be combined with other control structures for more complex workflows. Remember, understanding how to set up and control for loops, like defining the start, end, and step, is crucial for mastering programming logic. So, mastering for loops is a step toward writing smarter, more scalable code. All right, let's dive into slide 30, which focuses on the expanded for loop. So, we've already seen the basic for loop, but now we're going to explore how it can be extended to become even more powerful and flexible. The key idea here is that the expanded for loop allows us to iterate over more complex data structures, like lists, tuples, and other iterable objects, with ease. What makes this really important is that it simplifies our code, making it more readable and less error-prone. Instead of manually managing indices, we can directly work with the elements themselves. This ties into our overall theme of writing cleaner, more efficient code. Another critical point is that the expanded for loop can also be used with multiple variables, enabling us to unpack data structures on the fly. For example, when iterating over a list of tuples, we can directly access each component without extra steps. So, in essence, this feature enhances our ability to handle collections of data seamlessly, which is a cornerstone in programming, whether it's processing user input, managing datasets, or working with APIs. It's a small change that makes a big difference in how we write and understand our code. Let's take a closer look at the while loop. The while loop is a fundamental control structure in programming that allows us to repeat a block of code as long as a certain condition is true. It's particularly useful when we don't know in advance how many times we need to execute that code, but we do know the condition that determines whether to keep going. The key point here is that the condition is evaluated before each iteration. If the condition is true, the code inside the loop runs. If it becomes false, the loop stops. This makes while loops very flexible for processing data streams, waiting for specific events, or repeatedly checking for a condition to change. It's important to be cautious with while loops to avoid creating infinite loops, where the condition never becomes false, potentially causing the program to hang. To prevent that, ensure that something inside the loop eventually makes the condition false. In the context of our overall discussion on control structures, the while loop provides a powerful way to handle repetitive tasks dynamically, based on real-time conditions, rather than fixed counts. It's a vital tool in writing efficient, responsive code. Now, let's talk about list comprehensions. They're a really useful tool in Python, especially when you want to replace simple for loops. Essentially, list comprehensions allow you to create new lists quickly and concisely, often in just one line of code. They help make your code more readable and more Pythonic by reducing boilerplate. Think of them as a more elegant way to generate lists based on existing iterables, applying some transformation or filtering along the way. When you're working on data processing or creating new collections, list comprehensions can streamline your workflow and make your code cleaner. So, as we continue, keep in mind that mastering list comprehensions is a key step toward more efficient Python programming. Let's talk about the basic function. Essentially, this slide highlights the core role that this process or system plays. It's about understanding what it does at its most fundamental level. The key point here is that the basic function serves as the foundation for everything else built on top of it. Without a clear grasp of this core purpose, it's hard to see how everything else connects and works together. This function is what drives the overall efficiency and effectiveness of the entire system. It's like the engine that powers the whole operation. Recognizing this helps us see how each part contributes to the bigger picture, which ties back to our overall theme of understanding system fundamentals. So, in essence, mastering this basic function is crucial for improving, troubleshooting, or innovating within the system. Let's talk about function arguments. When we define functions, arguments are the values we pass into them so they can perform their tasks. These arguments are essential because they allow us to make our functions flexible and reusable. Think of them as the input data that the function needs to operate correctly. It's important to understand that arguments can be different types, like numbers, strings, or even other functions. And depending on how we set up our function, arguments can be required or optional, giving us more control over how functions behave. Remember, the way we pass these arguments, by position or by name, can affect how our functions are called and used. This plays a big role in writing clear and maintainable code. Overall, mastering function arguments helps us write more dynamic and adaptable programs, which is a key part of building robust software solutions. Now, let's move on to the concept of arbitrary arguments. This is a powerful feature in Python that allows us to create functions that can accept a flexible number of arguments. Instead of defining a fixed number of parameters, we can use special syntax to handle any number of inputs. This is particularly useful when you're not sure how many arguments might be passed to your function in advance. Think of it as giving your function the ability to be more adaptable, making your code more reusable and elegant. The key point here is understanding how to use args, which is the conventional way to handle arbitrary arguments. When you see args in a function definition, it means that all extra positional arguments will be collected into a tuple named args. This way, you can iterate over them or process them as needed. Remember, this concept ties back to the overall theme of writing flexible and efficient code by allowing functions to handle various input scenarios gracefully. Let's take a closer look at Fibonacci. Fibonacci is a sequence of numbers where each number is the sum of the two preceding ones. It starts with 0 and 1, so the sequence begins 0, 1, 1, 2, 3, 5, 8, and so on. This sequence isn't just a mathematical curiosity. It appears frequently in nature, from the arrangement of leaves on a stem to the spiral shells of certain mollusks. The key concept here is how this pattern reflects natural growth and aesthetics, which is why it's so relevant in fields like design, architecture, and even financial markets. When we understand Fibonacci, we're actually tapping into a fundamental pattern of how the world is structured, reinforcing the overall theme of discovering universal principles that guide complex systems. Now, let's take a closer look at the Fibonacci generator. This concept is fascinating because it forms the basis for many algorithms and models in computer science and mathematics. Essentially, the Fibonacci generator creates a sequence where each number is the sum of the two preceding ones. This sequence begins with 0 and 1, and then continues infinitely. What's really interesting is how this simple rule leads to a pattern that appears frequently in nature, like in the arrangement of leaves or the spiral shells of certain mollusks. In the context of our overall theme, the Fibonacci generator demonstrates how simple recursive processes can produce complex and beautiful patterns. It also highlights the importance of understanding these fundamental sequences when designing algorithms or analyzing natural phenomena. So, in essence, it's a powerful example of how basic mathematical principles underpin a wide range of applications, from coding to biology. Now, let's talk about class attributes. Attributes that we assign directly at the point of class declaration should always be immutable. This means once we set them, we don't want these values to change throughout the lifetime of the class. It helps maintain consistency and prevents accidental modifications that could lead to bugs. By keeping class attributes immutable, we're also making our code more predictable and easier to debug. Remember, these attributes are shared across all instances of the class, so their stability is crucial for reliable behavior. This approach ties into our overall theme of writing clean, maintainable code. Ensuring that certain core attributes stay constant helps us avoid unintended side effects. So, always think carefully about which attributes should be immutable and set them at the class level accordingly. Now, let's take a closer look at class methods. These are special kinds of methods that are associated with the class itself rather than any individual instance. Think of them as tools that operate at the class level, allowing us to modify or access class-wide data. One key point to remember is that class methods are defined using a specific decorator, typically at class method, which signals to Python that this method works with the class rather than an object. This becomes especially useful when we need to create factory methods or manage shared resources. Connecting this to the overall theme of object-oriented programming, class methods help us maintain clean, organized code by providing functionality that applies broadly to the class as a whole. So, understanding how and when to use class methods is fundamental for designing flexible and efficient classes. Let's now move on to slide 43, which focuses on class instantiation and attribute access. When we talk about instantiating a class, we're essentially creating an object based on that class blueprint. Think of the class as a template, and each object or instance is a specific realization of that template. This process is crucial because it allows us to work with real data or real-world entities in our programs. Once we've created an instance, accessing its attributes is straightforward. We simply use the dot notation to retrieve or modify values stored within that object. This is a fundamental concept because it highlights how objects encapsulate both data and behaviors, making our code more organized and modular. Connecting this to our overall theme, understanding how to instantiate classes and access their attributes empowers us to build more dynamic and flexible programs. It's the foundation for implementing real-world models within our code, making our applications more intuitive and easier to maintain. All right, let's dive into slide 44, which covers class inheritance. Class inheritance is a fundamental concept in object-oriented programming that allows us to create new classes based on existing ones. Think of it like inheriting traits from your parents. Your new class, or child class, can take on properties and behaviors from the parent class. This promotes code reusability because you don't have to rewrite common features. Instead, you extend them. For example, if you have a general class called vehicle, you can inherit from it to create more specific classes like car or truck, which inherit common features but also have their unique attributes. This connection between classes helps organize code logically and makes it easier to maintain and expand over time. Understanding inheritance is key because it ties into the overall theme of building scalable, efficient software by leveraging existing code structures. Let's talk about Python's way of handling class attributes and methods. First, you'll notice that Python doesn't have formal interfaces like some other languages. Instead, it relies on conventions and duck typing. When it comes to privacy, Python uses a nomming convention where private attributes start with double underscores, but it's important to remember they don't truly end there. They just indicate that these attributes are intended to be private, but they can still be accessed if needed. This means there are no real private attributes or functions enforced by the language. It's more about convention and developer discipline. Now, Python does have special class methods that are quite important. These start and end with double underscores as well. Think of methods like init for initialization, doc for documentation, CMP for comparisons, and SDR for string representations. These special methods enable Python to interact seamlessly with objects, providing a consistent and flexible way to define behavior. So overall, Python's approach emphasizes simplicity and readability, relying on conventions rather than strict access controls, but still providing powerful tools through these special methods. Let's talk about imports. Imports are really powerful because they allow us to isolate our code and reuse it across different parts of our project. This means we can write a piece of code once and then bring it into other files or modules without rewriting it. When we use imports, we're essentially adding references to variables, classes, functions, or even entire modules into our current namespace. Think of it like bringing in a toolkit. You get access to all the tools you need without cluttering your workspace with unnecessary stuff. This not only keeps our code organized, but also makes it more efficient and easier to maintain. And as we move forward in this course, understanding how to use imports effectively will be key to writing clean, modular, and scalable Python programs. Let's take a look at an example of imports. When we talk about imports, we're referring to how a country or a business brings in goods or services from outside sources. This is a key aspect of international trade and can significantly impact a country's economy. For instance, imports can include raw materials, manufactured goods, or even technology. The main point to remember is that imports are essential for meeting demand that domestic production can't fulfill, or for accessing cheaper or higher quality goods. They also play a crucial role in balancing trade and maintaining economic relationships between countries. Connecting this to our overall theme, understanding imports helps us see how global interconnectedness works in practice, influencing everything from pricing to innovation. It's a fundamental piece of the larger puzzle of international economics. Now, let's talk about the idea of more imports. As we look at expanding our supply chain, bringing in additional imports can be a strategic move. It allows us to access a wider variety of goods, often at lower costs, which can boost our competitiveness in the market. More imports can also help us meet increasing consumer demand or fill gaps in our domestic production. However, it's important to balance this with potential challenges like supply chain complexity or trade restrictions. Overall, increasing imports can be a powerful way to support growth and innovation when managed thoughtfully, tying back to our broader goal of building a resilient and adaptable business. Now, let's move on to slide 49, which covers error handling. Error handling is a crucial aspect of any system because, as we all know, errors are inevitable. The key point here is that effective error handling helps us maintain stability and improve user experience. It involves anticipating potential issues and designing our systems to gracefully manage these situations without crashing or causing confusion. For example, providing clear and helpful error messages can guide users to resolve problems on their own, reducing frustration. Another important concept is logging errors properly. This allows us to diagnose issues quickly and improve our system over time. Connecting this to our overall theme, robust error handling is essential for building reliable, resilient applications that users can trust. So, in summary, investing in good error handling practices not only prevents small issues from escalating, but also reinforces the integrity of our entire system. Let's talk about docstrings. Docstrings are essentially the documentation strings we include directly in our code. They serve as a built-in way to explain what a particular function, class, or module does. This is incredibly important because it helps both us and others understand the purpose and usage without having to dig through the code itself. One of the key points here is that well-written docstrings improve code readability and maintainability. They act as a form of inline documentation, making it easier to generate external documentation or just quickly grasp what a piece of code is supposed to do. Another important aspect is that many tools and IDEs can automatically extract and display docstrings, making our development process smoother. This aligns perfectly with the overall theme of writing clear, understandable, and maintainable code. So, in summary, think of docstrings as the comments that actually speak for the code, helping us and others understand and use our code more efficiently. Now, let's take a look at some of the popular web frameworks that have shaped web development. Starting with Django, it's known for its robustness and ease of use, providing a lot of built-in features that help developers build secure and scalable applications quickly. Moving on to TurboGears, which emphasizes flexibility and modularity, allowing developers to pick and choose components as needed. Flask is another key player. It's lightweight and minimalist, giving developers the freedom to design their application architecture from scratch. Zope and Pylons, although perhaps less mainstream today, played significant roles in the evolution of web frameworks by fostering a more flexible and component-based approach. And finally, Grok, which builds on Zope technology, aims to simplify development through its convention over configuration philosophy. These frameworks collectively illustrate the diversity and innovation in web development, highlighting how tools evolve to meet different needs and preferences, ultimately empowering developers to create dynamic, efficient web applications. Let's talk about some popular integrated development environments, or IDEs, that developers use to write and manage their code. First up, we have Emacs. It's a highly customizable and powerful editor that many programmers have used for decades. Then there's Vim, which is known for its efficiency and keyboard-driven editing style, great for those who want a fast, lightweight tool. Moving on, Komodo is another versatile IDE that supports multiple languages and offers a user-friendly interface. PyCharm is particularly popular among Python developers because it provides intelligent code assistance, debugging, and integrated tools that make coding smoother. Lastly, Eclipse, especially with the PyDev plugin, is widely used for Python development, benefiting from its extensibility and robust features. Overall, choosing the right IDE can significantly enhance your productivity and help you focus more on solving problems rather than managing your environment. Let's talk about package management. This is a crucial part of modern software development because it helps us handle dependencies efficiently. Essentially, package management systems allow us to easily install, update, and manage libraries or modules that our projects rely on. They save us time and reduce errors by automating these processes. One key point is that package managers also help ensure consistency across different environments. For example, if you're working on a team, everyone can use the same package versions, which minimizes the infamous "it works on my machine" problem. Another important aspect is that package managers often come with repositories, centralized collections of software packages, that make it simple to find and incorporate new tools or updates. Popular examples include NPM for JavaScript, pip for Python, and Maven for Java. In the context of our overall theme, effective package management is fundamental for streamlining development workflows, maintaining code quality, and ensuring that our applications are secure and up to date. It's really about making our lives easier while keeping projects reliable and scalable. Let's take a look at some valuable resources that can help you deepen your understanding of Python and web development. First, there's the official Python website at python.org, which is a great place to find documentation, tutorials, and updates directly from the creators. Next, dive into Python. Org offers a hands-on, practical approach to learning Python through a series of lessons and exercises, making it ideal for beginners and those looking to reinforce their skills. Lastly, the Django project. ComSite is the go-to resource for learning about Django, a powerful web framework built with Python. These resources are essential for anyone looking to expand their knowledge, stay current, and develop their projects with confidence. Remember, leveraging these sites can really accelerate your learning journey and help you become more proficient in Python and web development. So, if you're interested in learning more about Python programming, I've compiled some valuable resources for you. First, there are online courses and free PDF books that can help you get started or deepen your understanding. These resources are great for self-paced learning and cover a wide range of topics. Next, I recommend checking out Python exercises and solution PDFs, which are fantastic for practicing and testing your skills. Working through these problems can really solidify your understanding of core concepts. For those of you who enjoy hands-on projects, there are Python mini projects designed specifically for beginners. These projects are practical and fun, helping you apply what you've learned in a real-world context. Additionally, there's a comprehensive Python 3.7 tutorial PDF that includes exercises to reinforce learning. And if you have questions along the way, there are free PDFs with questions and answers to clarify common doubts. All of these resources align with the overall goal of mastering Python, programming efficiently and effectively. They're excellent tools to support your learning journey, whether you're just starting out or looking to expand your skills further.